All right. Hello, 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 hello. All right. So we have been we looked at the first part of section number 7. And the first part of section number 7 spoke about the absolute and relative change, right? Let me recap that. Now, absolute change, right, is your new minus your old, basically. All right. And when you do this subtraction, if you get a positive result, you interpret as what? An increase. And if you do this subtraction and you have a negative outcome, you interpret that as what? A decrease. Okay. And now we also spoke about relative change. But before I do that, now let me give you some words that will help you to identify what's your new and what's your old. So if you see 2, when there's no time reference, 2 will help you to identify the new. And then the word from will help you to identify the old when there's no time reference. Now we said that relative change is your new, okay, let me write that in full, minus your old. And if you have to put all these numbers together, make sure you introduce parentheses before you divide by your old. And again, 2 will help you to identify your new, from will help you to identify your old. And relative change is always a percentage change. When you have found your answer, you have to multiply this by 100, okay, to change that to a percent. Is that okay? So basically, that's all we discussed. And just like this, if you have a positive answer, you interpret that as an increase. And if you have a negative answer, you interpret that as what? A decrease. Is that okay? Nice. So this generally summarizes the whole first part of section 7. All right, now we want to talk about percentage change. All right, percentage change. And so we're going to use the proportions to discuss. Now, this is really very significant, and we're going to see some very important applications of this. Okay. Now, one of the most important things that I highlight to my students is that this question is very important. Lastly, does getting a 10% cut in taxes each year for 3 years equal a 30% cut in taxes? Okay, or does getting a 10% increase in salary and a subsequent decrease in salary give you the same amount? So we're going to look at some really very important applications of this. And if you understand this, you never get shortchanged. All right. Now, some companies use this tactic a lot, and it's important that students understand how these things really work. All right. So we look at some practical scenarios of how this really works, and we look at how we can interpret this using really in sentences, basically. All right. Now, you remember we looked at a formula like this in our earlier discussion when we were dealing with percentages. So you can, we said this was the amount and that was the base. So in this regard, you could as well represent this as the after and before, and then you have the percent over 100. Is that okay? Nice. And we are still working with the proportions. So when you have a proportion established, what do you have to do? You cross product and you find your variable or what you need to find. All right. Now here, earlier we learned how to calculate relative changes in order to make comparisons using percent change statements. In this section, the percent change and one of the values in the comparison is known, and we are asked to find the unknown value in the comparison. So here, for example, the FMR rate in Gary is 25% more than in Muncie, where it is $635. How do we find the rental rate in Gary? You will answer this question below. First, let's focus on 25% more part, okay? Now, if Gary's rate is 25% more than Muncie, then Gary's rate is what? 125% of the rental rates in Muncie. And let's look at that. So here, we will come back to this problem, right? But before we look at it, I want you to understand some of these phrases, how they are used. So if I say 10% less than, that means what? I will take 10% from 100. So 100 is the whole. So anything less we take from 100, right? Now, if it says 10% more, you add to 100. 25% decrease, you take away from what? You take 25 from 100, and lower, you do that, less. So take note of these phrases. We're going to see them a lot, all right? And we'll be using them to solve these problems. So 18 greater, you add, 50 increase, you add, okay, and 100 increase, you add. Is that okay? So note these phrases and as they are used in the word problems, and we use them to simplify answers. Now, so here we use the proportional approach, and I want to demystify this, okay? So another way you can do this is that, like I like to do, I'll put Muncie, and we are talking about what? Muncie and Gary, and I'll call this percent, okay, and I'll call this rent. Now it says rental rates in Gary are 25% more. So under the percent, 25% more, so I'll add to 100. So I have that right there, okay? And it says that where they are in Muncie, where they are 635. So it gives you the rental rate for Muncie as 635. Okay. Now, because Muncie is the original, we will maintain that at 100%. And now we want to find the rental rate in Gary. We don't know that, so we put X. So we divide, and we cross product. And our answer, if you do that, our answer will come out as $793.75. Is that okay? Nice. We'll take some more examples. So, okay, nice. Here we're talking about, we want to rewrite the following statements using percent of and solve, right? So here, Lafayette's population is 15% less than, so we're talking about Lafayette. Okay, let me use LAF for Lafayette, and we're talking about what? Bloomington. And we are talking about percents and population. So Lafayette's population is 15 less. So under the percent, we will do 15 less. So we have to take that from 100. Bloomington's population, which is 82,000. So we have the value for Bloomington's population. Now, because we are comparing that to the original population of Bloomington, we will now use 100 to represent Bloomington's population, because that is what we are comparing to. All right, now we want to find Lafayette's population, so we don't know that, we say that is what? X. So now we cross product and we simplify that, okay? And our answer, if you do this, will come out as what? 69,700. Is that okay? And that simplifies that. Now let's go to number 3. Rental rates in Fort Wayne are that, which is, so we're talking about Fort Wayne, okay? And we are talking about Indianapolis. Okay, so I'll put my percent here, and then I'll put my rent right there. Fort Wayne is Rent is 687. So I put 687 under rent, which is, so this number is 13.2 less. So I'll do 100 minus 13.2. Okay. Now, because that is being compared to Indianapolis, Indianapolis percentage will be 100%. Now we want to find the rental rate in Indianapolis. We don't know, so we put that as our X. Now we divide and divide both sides, and now we can cross product. And our answer will come out as 791.47. Is that okay? Good. So again, I focus on extracting the relevant information, okay? Laying them side by side, establishing my proportion, and then I will cross product to find my missing variable, okay? So again, let's do that again. So Indianapolis has a population of that. So we're talking about Indy and Chicago, okay? So we have percent, and again, we're talking about population. So Indianapolis has a population of, so I'll put under population of Indy, I'll put that 866, okay, which is 63.3 less. So it's 63.3 less, so I have to take away from 100, okay? Now, because that is being compared to Chicago, that population will be represented as a percent, as 100%. And now we want the population for Chicago, which we put X. Now we divide, and cross product. Okay, and that should come out as 2.7 million approximately. Okay, so extraction. Okay, nice. Now, I don't want to say that this is the only way you can do that, right? So there are other ways to solve these percentage problems. You can decide to, so you could have decided to do, so for instance, for this example, talking about Indianapolis, you could have decided to do 68.3% of Indianapolis population, and then you take that out from the value you were given the population you already have. So there are other ways you can do that, but I feel extracting the relevant information will be a very helpful one. So for instance, Jerry is currently earning $20 an hour at his job. He will get a 15% increase with his new promotion. Okay, what I can decide to do is I can do 15% of $20 and add it to $20. And that will give me what? $23. That works as well. Is that okay? Nice. All right. So the number of hardwired residential phone lines is expected to decrease next year by 18%. So I decide what I can do is I can decide to do this year. We're talking about this year, and next year. So percent. Okay, and what are we talking about? Wires. Okay, so let me go put wires. So the number of hardwired residential phone lines is expected to decrease next year. Okay, so next year is supposed to decrease by 18%. So I will do 100 minus 18, and then next year. With the widespread use of cell phones, there were 1.8 million hardwired residential phone lines this year. So this gives me 1.8 million. And a million is what? 10 to the 6. Now, because we are comparing, the original is, we are comparing to this year, that takes 100%. Now, how many are expected next year? We don't know that. We put X for next year, and we do that, and then we cross product and simplify. Okay. So that is how you go about this. Again, there are more alternative ways to do this. Okay. So, good. Now, Pete paid for an iPad. Okay. So here, this is a very controversial problem. When we are going to look at if you tried it the other way, we will see how that would have worked. So we're talking about Pete and Elaine. So Elaine and Pete, right? And then we have percent, and then we have the cost right there. So Pete paid $350 for an iPad. So Pete paid $350 for an iPad. All right, that, and Elaine claims that was 20% more. So he claims this amount was 20% more. So we have to add that to 100. Then she paid for a Samsung. How much did Elaine pay? So Elaine's is the one being compared to. So we keep that as the original, and then we want to find how much she paid. And we'll cross product, and our answer should be, okay, should be 291.67. Is that okay? I can clean that. 291.67. Now, if you did 20% of 350 and subtracted from the result from 350, you wouldn't get the same answer. Okay, so sometimes when you just want to do the percentage of the amount, add or subtract, sometimes there are limitations, but the process I'm taking you through really works for almost all the time. So you have to be careful and mindful how you approach these kind of problems. Okay, nice. So that's the question. So Megan is currently enrolled in a 16 credit out, but wants to decrease her credit by 25% in the summer. So you want to talk about what you're talking about, current, okay, and summer or future. And we have percents. And then what do you have? You have credits or costs. Okay, so costs. So Megan is currently enrolled in 16 credit. Are we doing, yeah, we're actually doing credit. So let me put credit right there. Okay, but she wants to decrease her credit by 24%. So 25. So, so currently enrolled in 16, but she wants to decrease in the summer. She wants to decrease that by 25%. So I would do 100 minus 25. How many credits will she take in the summer? So we do not know how many credits, Megan. So because we are comparing it to the current, that takes a percentage of 100, or the original, okay? So you do that, and you cross product, and you realize that Megan would do 12 credits in the summer. Okay, nice, so 12 credits, Megan. All right, nice. So really, what you could have done here, simply, you could have done 0.25 times 16, and that will give you 4. And then you take 4 from 16, and that gives you the answer as 12. So there are alternative ways to do that all the time. Now, if the take-home pay is $1,443 and 22% was withheld in taxes, what is your gross pay? So your gross is how much you get without, you're supposed to get without taxes before taxes are applied. And your take home always usually referred to as the net. The net is after taxes. Is that okay? So if you take home, so if I want to do the net and gross, okay? And then I have the percent right there and amounts if I want. So if your take home pay is that, so that's it, right? 1443 and 22% withheld in taxes. So that is it, minus 22, and that's how much I take home. Okay, now we want to know your original. I actually switched these positions, so let me make this the amount and the percent instead. Okay, so I want to know my original, how much I take home before taxes, and I can do that, and my answer will come out as 1,850. Is that okay? All right, so if you feel your brain is being fried, you can take a break. But really, these are very straightforward and fun examples. So Julianne recently joined a carpool, although she lives 22 miles from her work. On her day to drive the carpool, she drives 30 miles, 30% further to pick her up to join her colleagues. And how far does she drive? And that should be 28.6, okay? So having known this, I can take you through the rest pretty simply. Okay, so 425 million at the box office in 2013. And that was 32% more than Fast and Furious. And you do that, and then you get the amount for Fast and Furious, okay? And Jane spent $18 on lunch, which is 25% more than Bob spent. Okay, so again, you're talking about Jane, Bob, and you can do this alternatively, right? If you don't want to go through this process, you can always have an alternative around it. So Jane spent $18, which is 25% more. So I'll add that to 100, which is 125, more than what Bob spent. So Bob's percentage is the original rate. Is that what's being compared to? And we want to know how much Bob spent. And then I'll cross product, and we will know that Bob spent $14.4. Okay, nice. All right, now here we are going to look at changes in percentage points. Okay, and these are very important. Okay, so here's a statement that is too vague. A teacher says that grades will be increased by 10% for perfect attendance. Suppose a student has 52% in class and perfect attendance. What grade does the student receive if the teacher asks 10%? So if the teacher just asks 10%, the student gets what? 62%, which is a D. Now, what grades does the student receive if the teacher increases their grade by 10%? So look at it. So 1.1 means that the teacher added 10%. So that is why we have 1.1. And then we multiply by 52. That is what the grade the student receives, okay? And now the student has an F, okay? So 1.1 is coming from the fact that if I add 10 to that, that will be 110 divided by 100, and that will give me 1.1. So it's a vague statement, and the purpose of this class is to avoid vague statements, right? We want to be as precise as possible, very factual. So we state with numbers, okay? We want to clarify. Now, these are stuff that I would want us to be exploring. So relative has a percent, not a percentage points, okay? And we have dealt with these already. So I'll just pop out these answers and think through them, and you realize that this really makes sense. So here we're going to look at how we can choose the most appropriate based on these articles. So give them a try. Okay, try reading it and see, but I'm giving you the answer right away. And this is the most appropriate result. Think through it. And here, this is where this is really very significant, very important to me. I really want to take my time to explain this to you. Now, does a 20% increase followed by a 20% decrease net to zero? Does a 15% increase followed by another 15% increase equal to a 30% increase? To answer this type of question, we want to work through this problem. Now, think about it. Okay, think about it. I say that, okay, I am your company. So your company says that we are going to, things are not good. We have COVID, so we're going to cut everybody's salary by 20%. And now when COVID is over, we are going to increase your salary by 20%. We want to see if that will bring you back to your original position, how much you were receiving before COVID came in. All right. And let's see how intriguing this really is. Okay. Nice. So scenario number one, times are hard. So everyone at a small company you work for has been given 10% cut in pay with a promise of a 10% increase when profits improve. Okay, now estimate the number of hours worked in a year at 40 hours per week. Now in a year, there are 52 weeks in a year. So if we multiply every week you do 40 hours, we multiply that by that. And then in a year, you are doing 2,080 hours. Okay, now follow through systematically. If you are currently making $15 per hour, you want to estimate how much you make at the end of the year. So now we are going to multiply $15 by the number of hours you work in a year. Is that okay? Nice. So this is the rule of thumb to figure out how much annual your work. Now, how much will your reduced hourly pay rate be? So we're going to reduce your hourly pay rate by 10%. So we will do 10%. So we are reducing it. So we have to do 90 minus 10, 100 minus 10 over 100, and then we multiply by $15. Okay, so we have 90 over 100 multiplied by $15, and this is 0.9. So that's why we have 0.9 right there, multiplied by $15, and that gives you $13.5. So this is how much your reduced hourly pay becomes, right? Now using the rate, what is so now using the reduced pay rate, what is a 10% pay increase? So now we are going to do a 10% increase of 13.5. Okay, so we did this because we increased back by 10%. Okay, and 13.50, and this is 110 over that. That is 1.1 times 13.5. You see where it brings you back to? So really, it does not take you back to the original position. Okay. So how much pay would that be annually? So annually, this is going to be what? 30,088. 888. Now, look at it. Does the annual pay after the 10% increase equal what you got before the 10% cut and 10% pay cut? No. Is that okay? So it will not take you back to the original position because the percentages are being applied to two different values. Is that okay? So in the first instance, it was applied on a higher value. The decrease was applied on a higher value. than the increase. Is that okay? So it will not take you back to your original position. And note this closely. Anytime your company gives you that offer, think about it. Do the math before you make a decision. And I'll give you another scenario. You have been promised a raise of 40% with a new promotion. You have the option of getting the entire raise now or getting it in installments over the next 4 quarters at 10% per quarter. What option would you choose? Tell me about it. Will you go for the upfront 40% or you go for the 10%? What's your choice? Okay, let's get into it. Now, this is what I did. So option number 1, if I do the 40% upfront, that will be what? An increase of 40% over 100. So that is why so assuming that this is how much I receive, okay? So that is why this is giving me 1.4 multiplied by 12,500. And that gives me that amount. Now, if I want to go quarter by quarter, this is it. These are the quarter increments, 10%, 10%, 10%. Now, look at the difference. So at the end of the year, it's better to choose option than the first option, taking it upfront. Okay, because that will give you more money than taking it per quarter. Is that okay? So upfront. So these decisions are relevant to our survival, right? So you really have to pay attention because it will not take you back to the original position. So choices have to be made, and that is why this class is very relevant to our daily lives. Okay. So here, you're going to choose right. So read carefully, and I'll pop up the answers for you. And these are the most appropriate choices to make out of these options. Okay. Nice. Okay, so these are practice problems, really, and I'll take you through them one after the other. So Terry Holt, if you wanted to do the absolute change, this is the new, that is the old. We take that from there, and for absolute. And for relative, we have to do new minus old over the old, okay? And that is what all this is about, okay? And then for here, what is the estimated population of the city, the absolute change? And we wanted to find a relative change of that, okay? And same, right? Absolute changes, new minus the old. And that is interpreted as an increase because the result is positive, okay? And you want to put that in a meaningful sentence. That is what you do, okay? And more practice, if you wanted to do the absolute, is the new minus the old. So this indicates that nothing goes there. Okay, new minus old, okay? And you find that and find the relative changes, okay? All right, and that's basically how you go about it. So these are examples that have been done for you. Okay, so yeah. So go through these one after the other and check your result, okay? And let me know how you feel about these. Okay. Nice. So basically that brings us to the end of section number 7. Okay, in section number 8, we're going to be looking at another very important subject. Okay, and we'll be looking at linear models. Okay, and after linear models, we get into exponential models, and gradually we are coming to the end. Okay, so thank you very much, and as always, let me know if you have questions. Okay, so bye-bye. I look forward to hearing from you. Bye.